Margaret talking first, who's an architect and who's going to give us a kind of introduction to the topic of air tightness and efficiency. And then we've got Bart, who has got a lot of experience because he has actually gone through the process himself. And so he's going to talk about his own home and his experience there. And then we've got Adam, who's going to take us through, it's going to be really fantastic, a kind of live show of all his different products. Over to you, Margaret.
So hello, everybody. So I speak with a lot of people about energy use in their property. I'm a retrofit coordinator. I found that people do not know that much about air leakage or infiltration, another word for it, and how big its effect can be on the heat loss from your building or house. Bart is going to show us an example of how big this can be that's been calculated for his house. I also think that not enough attention is paid to preventing air leakage. In some countries, Germany, for example, where passive house comes from, the standards and the expectations are much tighter. Both in new build and in retrofit, a lot of attention has to be paid to techniques and also possible consequences of air tightness in buildings. The whole idea of this Open Eco Homes talk is to explore what we can gain from air tightness, how to achieve it, and what precautions to take. I believe that the benefits, particularly in these days of soaring energy prices, could be considerable and at relatively low cost. Our session today is a bit unusual. So rather than use a PowerPoint, Adam has promised to show us physically air tightness techniques in the demonstration area of his airtight paint company, air tightness products. And to take questions from you as he goes. So we'll see how that works. So the one crucial point I hope you people will take away today is about improving air tightness in your house. This applies to any house or building. And that is this: there is already a balance in a building that exists between the air supply, however it's got in, and a leaky building comes straight through the wall, and moisture control. So here's some aspects I'm going to look at. Leakage in the house, the humidity in the house, balance between them, the control of humidity and air tightness, the air tightness testing, and then building regs discusses 3 levels of air tightness, of ventilation provision. Okay. So here's a typical situation that Adam will doubtless be describing, showing the many locations of air leakage. So you can have your fireplace, up through light fittings in the ceiling, particularly recessed ones, voids in the wall, your loft hatch, service exits for servicing pipes, under the floorboards in the void, and then particularly around all doors and external doors and windows. However, there are other factors that work in your house, and you ignore these at your peril. On average, 4 people occupying a house for 14 hours produce 11 liters of moisture. And some sources even say more than that, 13. So here are some of the sources: breathing, cooking, drying clothes, showering. So this is my point. Unless your house is already producing condensation, which you're really in trouble, a leaky house is essentially working to dry and clear out the moist air from all that breathing. If you make the house less leaky, you must add controlled mechanical ventilation as you go. You can't wait to see. You don't want to know. You can't always see the mold. Otherwise, you may very well cause condensation of this moist air remaining inside, creating unhealthy conditions that may well lead to mold growth. Okay, so to repeat, we do want to prevent warmed air leaking out of the house in winter, and for that matter, you want to prevent warmed air getting into the house in the summer if your house is nice and cool. And we do want to extract the stale, moist air and bring in fresh air to breathe. And the key word here is control. Air tightness allows us to hold the warm, cooled air in, but we must also control the extraction and the supply when and where it's needed, and it's clearly needed. How do you know what level of control you need? You can borrow one of our CO2 meters, see how much stale air has been trapped. But an air tightness test will give you a reading of the level of leakage. This is our picture. An air tightness test is carried out by creating pressure in the house. And that's at the bottom there, at 50 pascals. Pascals is a level of pressure. The standard is 50 pressure, and the readings are taken at 50, at the level of 50. This is done with this blower door that's on our photo. Cranking up the pressure in the house or sucking it out. You can do it either way. And you measure then how long the house takes to return to normal. This gives you cubic meters per hour per meter squared. It tells us how much volume of air, that's the cubic meters, is getting through the internal surface of the house in square meters per hour. By the way, the photo on the right shows a thermal camera that can help identify where the house is leaking. An air tightness test can be a very, very useful starting point for your retrofit campaign. The cost of a test can be as little as £180. What are resulting measurements? Here are some examples. If your result is between 5 and 7 cubic meters per square meter, you can use natural ventilation with intermittent extract fans as defined in the building regulations. If it's lower, between 3 and 5 cubic meters per square meter, it requires a stronger system, and we're suggesting decentralized extract ventilation system. It's really not going to supply enough if you're that airtight for all those liters of moisture you're generating. And finally, if it's below 3 cubic meters per hour per meter squared, it is essential that a full house ventilation system is designed and installed, taking account of the whole house. And you'll notice that passive house requires even much lower, much greater air tightness, much less leakage than 3. So here's an example. This house was built in about 1930 in Cambridge. The volume's been calculated here. For the test, all the holes have been sealed. So that is the flues, extractors in the kitchen, the bathrooms, fixed vents. So the resulting air permeability is 7.03 per cubic meter per hour per meter squared. So this house is okay with basic building regs ventilation. And note that air changes per hour are not very far different from this measurement. That's relevant for people doing passive house. That's a similar way of measuring. Okay, so looking at building regs, the types of ventilation you could have. The idea is to extract from the wet spaces, as you probably know from baths and kitchens, and to supply to the living spaces, that is bedrooms and living rooms. 3 ventilation systems are identified in Building Regs Part F: intermittent extraction using background trickle vents. And that means that's IEV, and that means that the intake is uncontrolled. That's your basic leaky house. Mechanical extract ventilation, that's MEV, and the supply there can be demand controlled, and that allows you to save energy. And third, more controlled is continuous mechanical ventilation with heat recovery, and that's both supply and extract. And to go through briefly here, intermittent extraction, you have trickle vents in your windows and fans in the wet rooms, and this gives you the values for the kitchen, utility room, and the bathroom. Mechanical extract ventilation is if you have less than 5 cubic meters per meter squared per hour. You need, generally speaking, central fan and ductwork to and from all rooms. It can be quite difficult and costly to put into an old house, but it was used successfully in the Open Eco Homes getting off gas case. That was the Victorian house. Some of you may have seen that, and it's available on the website. And this is MVHR, mechanical ventilation with heat recovery, which is critical if you want to achieve passive house standards. That's air permeability of 3 cubic meters per meter squared per hour or less. And that is a massive ventilation strategy, including details, tapes, grommets, sealants, and paint, as Adam's going to tell us. And to achieve this, really, it's half the design and half the quality of work on site. The workmen really have to have a champion and to know what they're doing. And you'll need a central air handling unit. And this is actually being planned now for future OEH Open Eco Homes case study, which is now in construction. So, as I say, the essential conclusions are: it is essential to balance air tightness improvements with ventilation improvements. Consider an air tightness test to see where you are and what you will need to do, and then see examples of all these kinds of ventilation in the Open Eco Homes case studies. Thank you.
Thank you, Margaret. That was a really helpful introduction. And I think now we can move over to Bart, who's going to tell us about the specifics of his house. So Bart is obsessed with reducing the energy use in his house. He's done a load of work on it and seen some really dramatic results. So yeah, looking forward to hearing more about that.
Yeah, thanks for the kind introduction. What have I done? Well, bought a house a while ago, pretty standard 1940 semi EPC band D, if that tells you anything. Not particularly good, but also not bottom of the scale. And after 10 years of hands-on work, we added an extension, and that was basically the starting point of a deep retrofit to what hopefully sometime will adhere to NFIT standards. Happy to brag that we now have super insulated floors, super insulated walls and roof, triple glazing everywhere, windows and doors, and we've improved the air tightness quite dramatically and added ventilation with heat recovery. And the link on the slide there is to the Open Eco Homes case study. Before we embarked on all this, we had a whole house plan drawn up by the same architect who was contracted anyway to do the extension, because I thought the extension would have to be built to the standard to which I wanted my whole house eventually to be retrofitted. So the architect was well versed in passive house design. You know, his office is doing PHPP, the passive house planning package calculations, which is sort of a house simulation. So it takes into account the form factor, whether you're south facing or north, you know, all the bits and bobs. They visited and looked at the not so very good double glazing, the poor state of the doors and so on. and put all these numbers in the PHPP calculations, and then ended up with the pie diagram illustrating the heat loss on the slide. So Margaret already identified that infiltration is the ventilation you don't want, and the ventilation is what you do need. Now, if you add both of them up, you can see that the heat loss was almost half. So almost half of the heat, half the gas I burn ends up as, you know, hot air escaping. And okay, the ventilation you need, so that's 18%, but more than a quarter of the heat was infiltration. That is a lot. So I really thought like, well, you know, that is as much as all the heat loss through the walls and the roof and floors and the windows. So something really needs to be done. But of course, you have to realize, and I think this point has been stressed, but I can't stress it enough. You know, healthy homes need ventilation. We've got gas ovens or cookers, maybe wood burners, gas fires, back boilers, all open flame devices. And then there's the humans, you know, all these things exhale or produce CO2, CO, nitrous oxides, water vapor, and need oxygen. And for that, building regulations exist that prescribe how much ventilation there should be to achieve sort of a healthy environment where the humidity in your house stays between 40 and 60%. And that is, you know, if you make it too dry, you get all kinds of nasties that you don't want, certain viruses, bacteria. You get respiratory infections, you might get itchy skin, or, you know, allergies might be exacerbated. If you go too high with your humidity, you get mold growth, bacteria, dust mites increase, and the humide allergies and asthma might play up as well. So you do want to stay within that healthy range. So again, when you are getting serious about improving your air tightness and your planning measures, you should also at the same time really think about a ventilation strategy, or at least a plan how to achieve this healthy home, even though you address the air tightness and make it better. And again, you know, the CO2 is the best way to monitor your air refresh rates, although humidity measurement might of course help as well to monitor these things. But it depends on a lot more things than CO2. CO2, I would say, is the easiest way to measure how well your ventilation is doing. Now, a bit more, well, I would say practical, but it's not practical. What you should start off with when designing your air tightness layer or barrier, the idea is that, you know, you have a drawing of your house, and then you start to draw your air tightness barrier by putting your pencil on the paper and going around the whole drawing without lifting it. Now, in a two-dimensional drawing, this is a lot simpler than 3D reality. And you know, when you go to tradespeople, they can, you know, we know how to make a wall airtight. Wet plastering is one way to do it. We know how to make a floor airtight. You know, you can buy pretty good air tightness windows and doors, but the trouble starts when these two meet. You know, your window fitters will not care much about your wall, and your plasterer might not want to smear anything on your windows. So the trouble starts really when two of these meet. There's not many tradespeople, understandably, that feel responsible for the boundary. Although windows, I have to say, is improving. But there again, you arrive at the sort of the air tightness champion, who will, that person will then oversee during a build, you know, that all these boundaries where walls meet the roof, where the windows meet the wall, and so on, that those details are made airtight. And most of the time you rely on membranes, tapes, and all the other bits Adam will tell us about in a minute. Again, the trouble starts with retrofit, because previously it was mostly geared towards new builds, but retrofit, it is very difficult. If you go up to a builder and you ask them, please make my house airtight, most of them don't know what to do. Luckily, the next talk will be held by someone who very well knows what to do, but they are, I have to say, pretty rare, unfortunately. And there, I think it's best, so if the industry doesn't, in 9 out of 10 cases, doesn't know what to do, it's best to sort of inform yourself first. Go ahead, take the course and borrow a thermal imaging camera from Cambridge Carbon Footprint, and then see where the cold air enters your home. Or on a windy day in the winter, go around with the back of your hand or an incense stick and see where, see where you feel the drafts. Note these down, because I did it once and I forgot about all of them. So you really have to note it down. And then you can address the areas when you have time, you know, in summer or months later or the next day, whenever. Again, when you're serious about these things, then actually having a blower door test to assess the before situation is a very good point, because it knows how bad it is, basically. And also, you don't just rent the equipment, you also rent the people with it, and they've got lots of experience, and you will always learn something. But of course, I would advise you to prepare as best as you can. When you hire these people, you don't want to know about things you did not already know about. You know, you want to learn about new things. So in my experience, the extension was a new build, so that's relatively easy, I have to say. It was a very small project for any builder, so an air tightness champion really didn't make sense. It would have added so much overhead and cost. It would not be cost effective for small projects. And besides, I was going to, apart from the extension, phase the upgrades over so much time that, you know, this air tightness champion would have forgotten about everything 5 years down the line. So here DIY really made the difference. I had to do it basically myself. When the builders left for the weekend or in the evenings, I would go around and do the air tightness measures myself. So in the top right, you can see the roof light, and there, of course, you pick a roof light that has an air tightness skirt option you can order with it, and then you fit it. It's pretty straightforward. When the electrician has been and fitted all the back boxes, when he left, I took them out, put some gloop in to make it airtight, and put them back in again. And then there's the air tightness and membranes, and that really made the difference. It wasn't that much work, but you have to read about it or do a workshop and know what products you have to use. So it's a bit of homework, but the actual work itself is not that much. There's well-known problem areas, but I think I won't go through these because Margaret has, went through these already. So better spend some extra time on the examples I encountered and how I solved them. Not saying that is the way to do it. It's just a way of doing it. There's many roads that lead to Rome, and I'm sure that I might not have been the best clued up about the most modern products, and I think the next speaker will correct me on that one. So, for example, when some very loose plaster came down, I hacked it all off, and that was above a door I had to refit anyway. So that exposed some very shoddy brickwork on the top left picture. You can see the lintel, where the lintel sort of transitions in the brickwork, there's large cracks. And unfortunately, what's not really visible at the picture is behind the ceiling joist, were some very big gaps in the mortar as well. So you can actually feel the air coming through in the when it was windy outside. So there I applied some air tightness tape around all the edges in picture 2. You can see all the white tape with the holes. That is tape you can plaster over. That's quite handy. And then I cut a piece of plasterboard to size. I completely buttered it with plasterboard adhesive and pressed it into place. So you create a complete air tightness seal over the whole area. Very convenient for these kind of solutions. That's just one way of doing it. Another area where you're basically on your own was the opening where the old meets the new, where the extension met what used to be the outside wall. You know, where your big steel beams go where you walk under when you're going from the old into the new. It's very hard to design this beforehand with all the air tightness membranes. You just have to have your products ready, your membranes, your tapes, and just make it up as you go along, and make sure that you cover everything before it's being plastered or hidden from sight. So yeah, that was a bit of a tricky one, but we got there in the end. And then there's one particular one that was a bit nasty, was the sloping ceiling. There was a problem with the insulation anyway, so I had to take it out from the inside. And the left picture is what I encountered. There, as you can see, there is some issues with the insulation as well. One board was missing, one board has sagged down, and the holes to accommodate the joists were not cut so neatly. And there is, when you're talking about the risk of ventilation, we talk about mold, and that not only applies to the person living in the house having ill health, but of course your condensation can also affect your timbers, the roof timbers in this case. So here, what you see in the right picture is I applied a membrane all over the whole structure, and that also acts as a vapor control layer. It blocks the vapor from reaching the joists. So all that water vapor Margaret was talking about will not condensate on the joists and cause rot. And I have to say, please don't skimp on the quality of the tapes and the membranes. These will have to last a long time. They have to stay sticky, the tapes, then for a very long time. So, buy the good quality, don't skimp on it. And then again, when I got these air tightness improvements in place, you could note, it was notable that the indoor air got more and more stuffy more and more quickly. And alarmingly, the humidity levels went up to like 70%, which is really unhealthy territory. And then I had to sort of let, open windows in the middle of winter to let the cold air in, not very comfortable. Now, the plan was always to install active ventilation. So I really had to pull my socks up for that one and, get it done. Because once that was switched on, that basically rectified all the problems. There was no condensation on the windows any longer. The air felt fresh. There was no very high humidity levels anymore. It all settled in the desired range. At the moment, since we had this, and actually, this goes particularly for MVHR, but any sort of active ventilation Margaret already talked about will achieve this to some level. The ventilation levels are now much higher than before, so it's much healthier, and it doesn't depend on the weather. Normally, on a still summer evening, it gets very stuffy everywhere because the natural ventilation just doesn't cut it. On the other hand, when it's very windy, you probably overventilate. So with active ventilation, that is not the case. It does exactly ventilate as much you want at the time you want. And also another added benefit that is often overlooked is that it results in a defined flow plan. You've got inlets, you've got extracts, and the air flows from A to B, so you don't have any more cooking smells lingering in the bedroom and so on. Big advantage I sort of didn't think about until we had this system installed. So quick recap, and hopefully this will spur you into action. So improving the air tightness can reduce heat losses substantially, but you will need, when you're getting serious about it, a ventilation plan or a strategy to keep your home healthy. So first step I would suggest is to book the training and borrow a thermal camera from Cambridge Carbon Footprint, and then wait for a cold, windy day or book a blower door test to see where the air gets in and out. Then you map out the areas for improvement, you write them all down, and you start ticking these off until you're happy. And that's me for today.
That's great. Thank you, Bart.
Okay, well, I'm going to start from the beginning and then we'll go to my products towards the end, okay?
Perfect.
So I think first of all, we need to talk about what is a vapor control, what is a breather membrane, and just start from the very basics and then we can work from there. So in our building, we are going to need our breather membrane, which is our vapor control. Now, when we talk about breather membranes, we're not talking about breathing like we are now, in and out. You hear a lot of people say, our building needs to breathe, and we don't talk about it like that. That's probably a misrepresentation of what we mean, because what we're actually talking about is moisture that's traveling through our membranes. So there's a few different kind of membranes as well. So we have breather membranes and we have airtight vapor controls. So our breather membranes are actually our external membranes. So I'm drawing the build up somewhere just so you can look at the how they would look in a building. A bit crudely done. So if we said this, I know you're about retrofit, but to make it a visual, I'll show a timber frame building. So we've got our insulation in here. So a vapor control airtight membrane would go on the inside of the building. And what this is doing, it's stopping the air from traveling through, but it's still letting some moisture travel through the fabric of the building, only a very small amount. And these intelligent membranes operate over 80% humidity. They will actually open up and let moisture through. So if the building's struggling at any one time, it will let the building breathe. So that is what our vapor control is. and our airtight membrane. But we always forget about the wind-tight one as well on the externals. We always talk about internal membranes and moisture management, but it's really, really, really important that we look at breather membranes as well. Now, these breather membranes are actually wind-tight, but they're vapor open. So once any moisture gets into the building, it will let the moisture travel through at a faster rate. So the molecules on this one are bigger to let the building breathe, but they are waterproof. So it's like a rain screen. So if you're doing a so if you're doing a retrofit and you've got a rendered building, if you've got an opportunity to paint it and make it watertight and windtight, that is one of the first things I would say do, because if any of this structure is wet, this is a massive thermal break inside your building as well. So that is what the dip. So we've got vapor control, and that's what that's doing. Okay. I was a bit flustered from where my computer was playing with me, so I'll sped through that a bit. So where do vapor controls go? The internal one we're talking about now. Well, vapor controls go on the warm side of the insulation. So one of the first things you do with your retrofit is go, where am I going to stick my insulation? Am I going to stick it outside the building, or am I going to stick it on the inside of the building? And that will dictate where you can put your vapor control. Because if you look at a lot of council houses now that are being done, they actually stick their insulation on the outside of the building. That means we can actually stick our vapor control on the existing render block work. That you can go and spray your buildings, with a liquid membrane to make it airtight from the outside. So all this stuff you're doing on the inside doesn't actually have to be done. It can be done from the outside. Unfortunately, we don't live in a perfect world, and there's a lot of situations where we can't do that. So we're going to insulate from the inside of the building. So before we do any air tightness, we're going to do our insulation. So our insulation will go inside our brickwork here, and then our air tightness will go on top of that. So our new insulation, which we are roof insulation, our wall insulation. If we can do our floors, we will do our floors. I think, Bart, you've done yours. And then we will put our vapor control in. Airtight and vapor control. Now, you see I've drawn the floor, because a lot of people, when they're doing their retrofit, will actually ignore the floor area, which is probably one of the biggest air leaks you will get on one of these older buildings. So we used to run an air testing company. So me personally, I've done about 2,000 air tests myself. So running through it, the floor is one of the leakiest areas on an air test. And also on a lot of these buildings, older buildings, there's a lot of reports coming out because of radon coming through the ground as well. So to make sure you've got an airtight and radon barrier on the base is really important as well. We can hit on radon a bit later if we've got time at the end. One thing to realise before you use any products, liquid membranes on air tightness, or before you do any insulations, is ventilation. Ventilation is the first and foremost thing on any retrofit building that you need to look at. Now, I know that some people do get an air test and they say, okay, it hits the 7 log that we discussed before. But if we've got a house and say we're hitting a 7, all of the leaks could come from one area. So the most of this house could be relatively airtight. So if we don't do mechanical ventilation, natural ventilation is not going to look after this house. Notwithstanding, with natural ventilation, there's nothing natural about nature, and it won't be able to look after. It won't. If natural ventilation, if I've got 2 people in a house, and then I add a third, natural ventilation doesn't know I've added that third person, and then it doesn't know the cat's come upstairs, and I've got a cat there. Bit of a weird cat, but so he's up there. So the very first thing, when in all of our projects that we do, is ventilation is the first thing that we look at, be it decentralized or the centralized systems. So we'll move away from the board now from a bit. So what do liquid membranes look like? So this is what liquid membranes look like in a nutshell. Your whole building is turned either purple or another color from another brand. And this is spray applied, roll applied on your building. And this is after you've done your installation works, or it goes on the external side of the building. So every single part of your house will look completely airtight before you go on. So just people want to start asking me questions now, because obviously it's such a broad broad range of people out there. So I'll see what you've got on your own projects, and I can answer the questions before I go on off topic.
Adam, can you say what you do where those joists come into the wall?
So where the joists come into the wall, you'd normally see a joist hanger. So if this is a normal construction, you'd have there's a joist hanger here. You've either got a joist hanger with your joist coming out there. You would simply paint around that area. So the product is like an emulsion paint that you would paint on and seal everything. So just like where you try and go around with a mastic gun and seal everything, you're going around, it's like a Dulux paint. So you're going to go around and paint every single connection. So this is what new build and retrofit, they'll just go in there and just get up there and paint, or they'll get up and just spray all the areas over. And then it would look completely sealed. Like these areas here, they're sprayed on the whole thing.
Adam, you mentioned decentralized and centralized mechanical ventilation systems. So is that in addition to the membrane? So you would do the membrane or the paint, and then you would also have a system?
Yeah, well, that's with any system on retrofit. The very first thing you've got to look at is ventilation. Don't go, oh, I'm going to do insulation, then I'm going to do a bit of air tightness. No, the very first thing is, how am I going to ventilate this building? Natural ventilation, it's out. It's bollocks in the new term. Sorry, builders. It doesn't work. There's nothing natural about it. It can't cope with windy days. It's not going to come in right. Different windows and different amount of people. If I have a family in one room, that the CO2 levels and the VOCs are going to be quite high in there as well, and the moisture as well. The moisture is going to be in there. And different rooms will do different things, and they'll be leaky at different times. Like I said, you can go and get an air test, and it could say it's a 10. But 99.9 of that could come from one room. You're thinking it's really leaky, but the others could actually be pretty good. So your health benefits on that. So you've got a choice of decentralized units, which 2 seconds. So decentralized units is one of the first things I would grab if I was going to do a ventilation system to start with, if I'm worried about space. So these units here, I've just taken the cover off so you can see. So what they do, they go into every room. They do about 43 cubic meters per machine. So what they do, they suck for a minute, they suck all the bad air out, and you've got filters, and then they put it back in after a minute. So they heat this ceramic plate. When they pull the cold air back in, it warms itself back up. So these can be up to 90% efficient. So long gone are the days where they just suck in and blowing this cold air in and out. These are really efficient machines, and they go into all the habitable spaces. They go into the bathrooms, they go into the kitchens. You go into the bathroom, you can set it so it sucks the air out for another 60 seconds. So if you go to the toilet and you're in there, you want it on for maybe 2-3 minutes after you've been in there, or if you're in for a shower. But the good thing with these now is they'll actually talk to the other machines. So if this one's sucking for 3 minutes straight, it will talk to the other machines and tell them, hold on, I need a bit more air in this building. So it keeps it regulated. And they can also detect CO2 as well. The only downside to the centralized machines, they are quite clunky, and you do have big systems on the outside. I'd say big systems, bent systems on the outside, but on the inside you have to have square boxes. But again, these are coming forward a lot, so they're not the big chunky plastic things now. There's Corian ones, there's metal face ones, and they can look like art. So they're pretty good.
That's really. Are they noisy?
No, they're not noisy. What you've got to remember with these machines is when we put one in, we don't want it running at 100%. So we've got to make sure that we've got enough machines in and they're running at a speed it can handle. We don't want to run it right up to 100%, because then you'd hear it. It's the same as if you had a centralized system and put it on 100%. I would hear that in any room. So we've got to make sure the balance is right. We're making sure there's enough. So I've just done a project for West Midlands Safari. I've done all their luxury lodges, so I was the main contractor on that one. And I opted for decentralized because I just didn't have the space. I didn't have the space for the pipe work. And but in one of the rooms, I've actually got 3 units. It's an open plan kitchen. I've got 2 on one side and 1 on the other side. Keep it running down at a nice, efficient rate. Yeah, and they're fine. And they're good. If you want to turn them, if you want to turn it off at night and you don't want to hear it, you can turn it off. The option's there for you to do it as well, but you can hardly hear it.
Adam, can I ask you about your experience in air tightness?
Yeah.
Where were the 5 worst places you typically found in the houses you worked on?
Oh God. Do you know what? The worst one was a new build by Skanska Homes. But yeah, I couldn't sign it off. The floors are a big one. The floor and retrofit is always a big one, because it might be coming out of the floor in one corner, but the hole's actually the other side of the house, and it's just traveling through underneath the floor. It's so hard to get the floor right. It really is, and it's one of the biggest tackles for us when we're going on and doing our retrofit. So I own a construction company as well. We do renovation work, we do new build, we do everything, and the floors are one of my biggest bugbears with that. Although now we just spray all the floors because of the radon element, because of a lot of the buildings we have. Even if there's a small amount of radon, it's like being in a room with a smoker. It's only a small amount, but I don't want to smell it. So we always treat the floors, make sure they're airtight, make sure there's no nasty chemicals that can come out of the floor from what was there 50, 60, 80 years ago. Any other questions?
Adam, when you were showing your layers, when you were drawing, and you had sort of insulation on the inside, and then your product on top of it, so you have to insulate first. If you were in a situation where you can't put as much insulation in, is there any benefit to doing the air tightness? Presumably you lose any drafts. Is there a use for your product in just removing drafts, or do you
can you hear me?
have to do the whole thing?
It's like with any product, with any like heat recovery system, we all rely on everyone else. We can do it, but it's still not going to be as good as if we treat every element. So without my fellow components, I'm nothing. That's the first thing. So when someone says triple glazed windows, it's amazing, it's the only thing that's going to warm your house, that's lies, because without the air tightness around it, and without the thermal insulation and things to stop the warm air hitting the cold air, tell you what, back to board. So if we've got our wall build up, and I'm going to Air Tightness. I'm going to Air Tight. I didn't put any insulation on, and we haven't treated outside. We haven't made sure that's wind and water tight. Well, the wind and the water can get to here quite quick because I haven't treated this area. And then we've got the cold and the warm, and they're smack bang hitting each other. We've got condensation. We've got a water build up straight away because we haven't treated the outside. We've not looked after the render. We've not looked at the brickwork. We've not looked at details around the window on the external as well. A lot of people are always focused on just the inside of the building, but the outside is just as important as the inside. If we can do all this, if that cold and that cold air is being driven through gaps and the water's getting it, condensation, notwithstanding, if you imagine that that's a sponge and then you wet that sponge, the cold is going to get driven straight into the house. Massive thermal break for a little bit of detailing on the external. But yes, we can do it, but it's not going to be as good. And I wouldn't suggest it. I would always recommend trying to do a few things, not just the air tightness. And if you do the air tightness, you have to do the ventilation. So it stems back to ventilation first, ventilation, natural ventilation. I'll have a dog fight with anyone to the death who thinks it works, because there's nothing natural about it. It just won't work. And as we upgrade as well, over the next 5-10 years, we're going to be upgrading more grants. We've got to make sure our house can handle everything that we're doing.
Yeah.
I'm just going to step onto the windows just a little bit. It's outside of what the air tightness, but it was just because I was going to draw it. So retrofit with the windows, that's another important thing. To one, make sure they're good, decent windows and they're being installed right. So I've seen recently a lot of people doing insulation, air tightness, they're doing ventilation, but they're not looking at the windows. They're saying, oh, the guy said it doesn't matter, or this or that. Well, it does matter. It actually matters quite a bit, because this is what's going to happen inside your house. You're going to put this nice new insulation on. Find the right pen. We've insulated our house. We've paid all our money. Done a bit of ventilation as well. I'm 21 degrees, but I'm still unhappy. Feel cold. The wife's moaning. The kids are moaning. They want to put the heating up. Now the reason why is because we've made all this nice and warm, but we've got the hot air hitting our cheap window, and then it's dropping suddenly in temperature. So we're dropping, and we're actually making like a little wind tunnel inside our building, like a little vortex. So although it's 21 degrees in our house, I actually feel 18. It's like when you see a weather report, 21, feels 17, so there's a slight breeze. That is what you're doing inside your house by not looking after the windows and all their junctions, because it's cold hitting, or the warm air hitting the cold air, and I feel cold. So if you've ever been in an old building and you've sat there and went, someone's walked over my grave, you have little goose pimples over you, if you're like, oh, that's what happens in old houses. Hot air is hitting them cold windows, and you're getting a wind, you say it's windy in here. It's because of that situation magnified in a building, and that's what gives you the wind in these old houses, magnifying it. So windows, very important with retrofit as well. I'm not trying to make everyone spend their money and try and divert from my products, but it is really important in these junctions here as well, because you can have the best window in the world, but if you don't install it right, and we've got all of these sections here that are cold, well, the warm air is going to hit them and then do the same. We've got nice warm air, down we go, you're feeling cold, the wife's moaning and the kids are going nuts. So what they do, they end up putting it up to 24, 25, so they can fill their 21. And that's just cost you a load more money than it would have done to replace the windows over the next 5 years. Sorry, I'm standing in front of it. So just touching on the window, but any more questions?
Got one.
Yep. Yep.
I wanted to ask you what sort of things you can do for builders who have been asked. This is, a builder that somebody who's heard from Bart says to the builder, can you make my house airtight? What can you do for that builder?
What can I do? You need to know what kind of build up or wall build up it is. Are they stripping the build down? Are they doing the essentials? Have they looked at air tightness? There is one thing for me to say will not fit every project. Every project is a standalone project, and everyone has to understand it. This is why people come on classes like this, because it's a minefield. It really, really is a minefield, and there is no magic solution. There's a lot of components together that will work. And yes, if you go and put my paint around everywhere, we are one of the best leading products on the market. Nearly, I think 1 in 2 projects in the UK will be with Passive House. With the Passive House, we'll have our product Passive Purple on, and that goes around the world with our Passive Purple product. But every situation, if they're going to strip back the building, we can put Passive Purple on, and then we can plaster, or we can dot and dab and start again. Installation levels, I wouldn't know where to start. Each project needs to be looked at by someone specialist.
What I'm trying to get.
Don't make anything up. Don't make it. That's the biggest one. Don't guesstimate anything. Don't guess or go on YouTube and go, oh, I can do that. There's loads of people out there that will give advice. People like my company or any installation company, they should give you advice. If you say, Adam, I've got these drawings, do you reckon this detail will work? I can answer, one of my team would answer. There's lots of people in the industry. Even you, Margaret, you'd go around, you say, look, I think you should do this, but never just guess it, because every building's different as well.
So what I was hoping you might say was that people could come out to your site in Croydon near Royston to be trained.
Yeah, so we offer free afternoons. So we offer free training in intelligent membranes. We've got a facility here where we show people everywhere from retrofit to new build stuff. So all the retrofits outside, but we show everyone timber frame, all the different options. We show people air source heat pumps. We show people heat recovery machines. We've got the world's most airtight pub next door. The air tightness score on that was 0.07. So the second most airtight building in the world. There's only one other that's beating me, and that's from a project that used my product, which is the Duxford War Museum.
Oh, really? Wow.
That's a large scale building. Then mine's a small building, so I'm taking the accolade as the most airtight building or pub and flat. But yeah, we've got lots of technology down here to show people, and because of the way we do things and maybe it's a bit ad hoc, we're able to give the training for free as well. So if you write in and say, when's your next available date? You say, look, we've got this that afternoon, do an afternoon. We don't expect anything in return. Any other questions? There's a hand from Ian, is it?
Hi, yeah. How feasible is it to mix internal and external insulation? We've got solid walls, old house, solid walls, probably be building a new bit onto it, which will be, I expect, probably timber frame addition. How feasible is it to mix internal and external insulation?
When you say that, you mean, can you put a little bit externally and then a little bit internally as well? Is that
yeah, depending on the external walls, basically.
Yeah, I mean, you can mix insulation styles. You could have PI, you could have wood fibre on this side, and then render. You could have PIR on the inside.
There are not issues with condensation or something where you're changing.
Every situation, every wall build up that you do needs a condensation risk analysis, bar none. Every time you do a wall build up, look at it. So if you're going with a Celotex, send off the details to them and they will do it free of charge. Any installation company will do that condensation risk analysis for free. So it doesn't matter what company you pick, as long as you tell them, as long as you're using theirs in one of the build up, they will do that for free, or send a build up to me and I'll get it done.
Because if you're doing it internally, do you also have to effectively run it through the floors as well, through the internal floors?
It's always advisable to do the floors on an old building as well, because again, that's where a lot of the leaks come from. It's depending on the wall build up. So yeah, the floors get sprayed. A lot of the retrofit, I'd say 90% of all the retrofits we do, the floors get sprayed as well. But it could be there could be a damp issue as well. So you don't have a damp proof course, or you can't put any insulation on. We just can't go any lower. So then you take out your vapor control to a vapor block. It has to be a complete vapor block, and that will go down, which will be a liquid DPM. So you just got to be mindful which one you choose there. But again, any build up or anything you're doing, the specialist will give you advice. Like with us, if you would send me the details, or even write the details down, we can then draw them up. We have our own in-house design team who will draw it up and say, look, this is what it is, and here's the condensation risk analysis.
Right, because the same also goes for we've got suspended timber floors on the ground floor with some insulation that we put in some time ago underneath there. But again, to do that properly, to make them draft proof, because they're not very draft proof at the moment, again, I can see that there could be issues with, yeah, well, which way is the moisture going in that case? Because is it coming up through the floor, or is it actually going out?
It's going to do both. Moisture, that's the thing with moisture, it will go whichever way it wants sometimes. So with them, we normally would say overboard it with like a ply, and then paint a vapor control down there. So you're sealing everything up and then putting a vapor control over the whole top, depending on how gappy your floor is. Again,
and that's not going to cause it to get damp.
No, because anything over 80% humidity, that's why we have intelligent membranes. Anything over 80%, our product will actually open up. So if you think of our product or any intelligent vapor control as a bouncer on the door, he decides who comes into the club and who doesn't at the right time. So that's what a vapor control will do. He will let the people through as and when we need it. If it's going above 80, it'll open up, let the moisture go through until it goes back to normal, then it will stop. And it'll also work the other way as well. If it's getting too dry down there, if it goes below 20, it will open up as well and let some moisture through as well, because we don't want to be going below 20. So we'll balance it out. Like I say, if you think of it like the bouncer, he looks after the club, he makes sure that the right amount of people are there.
Yeah.
Thanks, Adam. So I think Sandra had some questions that she'd like to follow up, please. Sandra?
Yeah, it was Colin, actually.
Hello, Colin, you all right?
Yeah, mate. What about where you've got semis, the dividing wall or a row of terraced houses? Obviously, you can put the internal insulation on your side, but is there a problem, or if your neighbour's not going to do the same thing? Because
you've probably got a cavity between the two buildings anyway, so there's going to be a cavity there, and yeah, I mean, you'd normally treat that rule. The other side would be 17 degrees anyway, so there won't be no problem what your neighbour's doing. No, you just look after what you're doing on your side, and don't worry about them.
Okay, Sandra had a question as well.
Okay,
well, I think Bart may have answered it really in the chat. I was asked, we've got double glazing. When we've turned our heating down for the last couple of winters, then we've had condensation. There are only two of us in a very large house, so I wondered if that indicated poor double glazing, possibly.
No, I mean, that's ventilation. Yes, ventilation. There's a lot of moisture within the building. hitting the glass, and there we've got our moisture in there. So like Bart's probably, I can't see what Bart said, but he's going to say we need more ventilation in that house.
I'm so glad you backed me up, Adam.
Yeah,
I said exactly the same thing.
I can't see the chat. So yeah, maybe you need some more ventilation. Maybe you could just put a couple of the centralized machines in to handle. If there's only 2 of you there, you could put a couple in to see if it does any better for you. Take a look at what your bathroom ventilation is, your kitchen ventilation, maybe a few upgrades on there.
Yeah, actually, to add to this, I had the same issue when I did some air tightness improvement, but not enough insulation, that I would get a lot of condensation at night over the windows. But that was mostly because the curtains were fitting so well. So, you know, there was no airflow where the windows sat. So behind the curtains, it got really cold, and then you get loads of condensation. Well, so there needs to be a bit of airflow around these windows to take the water vapor away.
Yeah. But natural ventilation won't feel it.
Yeah, you know, it's difficult.
Yeah, it's so difficult because it just all boils down. You need mechanical ventilation in all these, even if it's a little bit, Sandra. If you can try with one, I would highly recommend it.
Yeah, but what's just been said is relevant actually, because we've got shutters at most, wooden shutters at most of our windows, and it was when I opened them I found the condensation. So there's no airflow, is there, between the shutters and the windows?
You've got the moisture, you've got the warm air moisture going through the shutters, hitting the glass, and it's just all staying there. It's just like a little bit mini build-up in there. So it's actually going to make it worse.
Yeah. Oh, thank you. And Bart, thank you very much.
That's great. I think Stuart's got a question as well. Stuart, over to you. Are you with us, Stuart?
Oh, he's at work. You can't talk. Do you want me to read it? Oh, you read it.
Okay, so Stuart says, 2 options we're looking at for insulating under suspended wooden floors is spray foam using a robot, or pulling up floorboards to add insulation, a vapor control layer, etc. What are the pros and cons of each of those options from an air tightness perspective?
Now, I'll probably sit in one of the parties that I actually like spray foam insulation, so I'll get killed by half the passive house people for saying that. The robot, though, I don't like it. I don't believe it can spray everywhere. It's messy, it's expensive. It is good, though. The U values would be a lot better using spray insulation than ripping the floor up and using maybe some wood fibre. Or anything like that. The pros of ripping the floor up is we can see everything, we can get to it, we can make sure the insulation's in there, it's all nice and tight, and we can then make sure our vapor control is in there. The downside is we've just ripped the whole floor up. But I'm in the camp, if you're going to do something properly, let's go for it the first time, so it's going to last us. If I'm 30, 40 years old, I know it's going to last me until my dying days because we've done it right. Not because we've paid a little robot that's gone in there and I think it's got everywhere. And I still need to put a vapor control in there.
We're saying that people who use the spray robot on under their floors generally need you, and then it went off.
Oh yeah, so spray foam, you'll find it hard push to find a spray foam that doesn't need a vapor control that is as vapor closed as our one. So a lot of spray foam companies actually buy my product to put on their product as well. So you'll need an additional, especially in the roof and the floors, you'll need an additional vapor control, and the spray foam alone won't work.
So that, just to clarify, in the roof, you put the insulation on first, and then the vapor barrier underneath, the air tightness barrier, and on the floor you put it in first, and then the insulation underneath.
No. You put it in. You put the insulation in first, and then you put the vapor control
on top.
Yeah, on top. The vapor control always stays on the warm side of the insulation. The breather membrane can go on the cold side. The vapor control can stay on the warm side.
So I'd like to thank all our wonderful speakers today. Thank you so much for your time and your expertise. And thank you to you all for attending.